Overall, at this time, were you aware that Whitehall itself was troubled by what it felt to be the anomalous position of power jets?
I don't know what the position was of the ministry with all the various undertakings they were trying to give to various people. They were telling power jets they would protect us. They were trying to get undertakings from the rover company, which the rover company refused to give. They were trying to get undertakings from the BTH company, which they were refusing to give. So they were in a first-class difficulty, really.
And it was this, presumably, that prompted their move towards Rolls-Royce, was it?
The situation became so bad that it looks as though there would be a complete hash of everything. The rover were making such a poor job of the engine that the order for the production of the meteor was cut right back. And then Sir Wilfrid Freeman at the ministry wanted to hand the whole job over to Rolls-Royce. I successfully resisted that. I think I did anyway. But nevertheless, Rolls-Royce did come into the picture in a big way, in that it was agreed that they would take over the job from the rover company and hand over to the rover company their tank engine, diesel engines they were making. And from the moment that Rolls-Royce took over, the picture changed completely.
How was the picture then at Clitheroe at Barn-Olswick at that time? Did you know?
At the end of 1942, rovers were just staggering along, getting 30 hours running out of, say, 6 engines. And as soon as my feeling is that they didn't want it to work because they wanted their B-26 to supersede the W-2B. Anyway, when Rolls-Royce took over, within 1 month, the running time jumped more than tenfold to over 400 hours.
And one of the main agents, at any rate, one of them behind this was Sir Stanley Hooker. What was your relationship with him, or Dr. Hooker, as he was then called?
The leading people in the Rolls-Royce team, which brought about this revolution, you might call it, was headed by Stanley Hooker. Dr. Hooker, as he then was, and Stanley Hooker, as he became later. He was a great leader. In 3 months, he and the team he had at Barnoldswick had the engine up to its full design performance, and in fact, shortly after, they improved on it. And the main reason they did that was they made a modification to the turbine, which I'd recommended 2 years earlier. That was just altering the angle of the turbine blades through 5 degrees, and that put the engine right, and it was able to go through its type test at full design performance.
Did you sorry about that, I'll start that again. Did you have much to do at that time with the presiding genius, Ernest Hives at Rolls?
Ernest Hives was the chief executive of Rolls-Royce, and he was responsible for the Rolls-Royce part in taking over the jet development, because he had come to realise that this was the future of the aero engine. And since Rolls-Royce then were one of the most prominent aero engine firms in the world, he wasn't going to be left out. He was I would call him an honest rogue, because when he was going to do the dirt, he told you he was in advance.
Did this happen to you?
And one of the things he said to me on one occasion was, he said, "We're going to be the centre of this job, and nothing you can do will stop us."
But in fact, your position at Power Jets was really, I mean, on a personal plane, was one of parity, really, wasn't it? You were quite happy to work alongside them, were you not?
We were quite happy to cooperate with Rolls, because they were willing to take full advantage of our experience and not make changes for the sake of making changes. And that worked fine. We got along fine with Rolls-Royce, and things really speeded up then.
What was your position vis-a-vis Dr. Oxby Cox at this time? Was he part of the ministry or part of the GTCC or what?
Things had improved a lot in the ministry while this was going on, in that there had been changes of organisation. Certain of the civil servants who'd been, well, pains in the neck, you might say, had been relieved of the job, and Roxby Cox, Dr. Roxby Cox, as he then was, became Director of Special Projects and supervised the whole thing. And the civil service management of the job was much improved.
So in 1943, you were looking forward to the possibility of having meteors flying, presumably.
By 1943, the Rolls-Royce having made such a big difference to the prospects of the engine, the ministry agreed to reinstate the production of the Meteor, and in fact they began to go into service in July and August of 1944 as a result of the changes in 1943.
Did you see some of the early flights of the Meteor?
The Meteor flew first with a de Havilland jet engine, the H1, later called the Goblin, in March the 5th, 1943. I was not present for that. I believe I was away at the Staff College or something.
You had at this time, and just come back to this, it's interesting, you had at this time quite a long stay in America too. How did you get on with your colleagues over there?
After the Americans had taken on the job, after about 6 months, after they actually had the engine running, it was agreed that I would go over and help them out. And so I went over at the end of May. But for various reasons, it took me about 7 days to get there. That's quite a long story in itself. But I got there just at the beginning of June and helped them. I went to Lynn under an assumed name. They insisted I use an assumed name. I called myself Whiteley because I thought if it wasn't sufficiently near my real name, I wouldn't recognise it if I was being paged or things of that kind. There were times when I forgot it, like in the hotel I would waking up and sign for my early morning coffee and forget that I was supposed to be using an assumed name and of course sign the real one.
You must have been a bit of a nightmare to security one way or another.
I'm told that that didn't matter really because the waiter was an FBI man.
Were you impressed technically by the work at GE? Were they good?
It was most satisfying to see the work GE were doing because, they got on with the job so fast. It was remarkable. And their enthusiasm was most inspiring. And I thought at the time, if only I'd had that kind of cooperation a few years earlier, what a difference it would have made.
Their engine was not, presumably, their final engine that they made for the Bell aircraft was not that dissimilar from your W1, correct? Or not?
The GE's first engine, which they call the Type I, was virtually our W2B. The only real changes they made were to the auxiliaries, like things like the fuel pump and other auxiliaries.
Which tended to show to you, at any rate, and your colleagues, that you were on the right line.
The fact that GE were following our line so closely was very encouraging. To have engineers of that calibre not arguing with what we'd done was quite satisfying.
And now I've come to 1944 and the public announcement. From the years of secrecy and struggle, you suddenly find yourself and your team find yourselves heroes. What were the circumstances of this? Do you remember?
We had been working in complete secrecy until early January 1944, at which time, for reasons I don't really know, the British and American governments decided to make an announcement about it. Maybe it was to just to show that how good the Allies were getting along. So there was a joint announcement on January the 7th of 1944. It was like the world blew up around me. The shock was very considerable to have been working in such complete secrecy for so long, and then to be exposed to this blaze of publicity was no end of a shock.
It must have been a puzzlement to those who knew that at the very time that the public announcements are made and you become a celebrity, that abruptly the Ministry of Aircraft Production decided to nationalise power jets. Can you tell me a little about that, and can you tell me what you think their reason was?
Power jets was nationalised in 1944. It was partly my fault because I realised that there was a complete mess. From the contractual point of view, there were no effective agreements, and the government had spent all the money except for the shareholders of power jets. Power jets were the only people who'd risked their money. Rolls-Royce hadn't risked a penny, Rovers hadn't risked a penny, de Havillands hadn't risked a penny. No one except power jets had risked any money, except the government, of course. And the government by that time had put in, I suppose, 2 million or so, maybe more. And I felt that the government having put in 2 million, as against private money, power jets money of about 20,000, that it should be nationalised, with all the companies forming a collective gas turbojet establishment, and of course I hoped that power jets would be at the top of the pyramid, with myself as chief engineer.
You go on to say in your book, in fact, that those who had founded an industry were deprived of the right to design and make experimental engines.
That was later.
Let me come back then to 1944. Now, the effect then of nationalisation was what? What were you doing? Put it this way, what were you designing and making at power jets after nationalisation?
In 1944, power jets had reached a point where they were able to produce, say, batches of 40 or 50 engines. We had that in the factory at Whetstone of about 80,000 square feet. And we were well equipped with a test plant. And we had all a first-class nucleus for a proper manufacturing organisation. But there was such a mess that when I made the suggestion that everyone should be nationalised as my solution to that mess, Sir Stafford Cripps, the Minister of Aircraft Production at that time, used what I'd said to get the ministry out of the mess that they created by nationalising power jets only, which relieved them of all their undertakings.
In the sense, in what sense was that so? They had the right to use your patents freely, and they presumably then had the right to use your facilities for batch manufacture. Is that how they finished up?
The nationalisation of power jets meant that the government really took back all the plant which they'd provided, so it became government property properly, and took over all the staff, and they planned to carry on power jets as it had been, but then other firms began to create difficulties. They said they weren't going to have the government competing with private enterprise, so considerable pressure was brought to bear on the ministry.
I'm sorry, this was the aero engine manufacturers themselves saying, hey, we're going to be free and we're not going to compete with a nationalised concern.
Yes, the aero engine firms took up the position that this was manufacture was not a government job, and it certainly wouldn't be right in their eyes for a government firm to compete with them. So again, to cut that particular Gordian knot, power jets was combined with the Royal Aircraft Establishment at Pystock to become the National Gas Turbine Establishment.
Manufacturers may have felt some reticence about, or some reluctance rather, to see you manufacture, but at that time your programme was fairly advanced, wasn't it?
At the time power jets was nationalised, we had some quite advanced projects going on. There was the LR1 turbofan, which would have been the first turbofan in the world. There was the engine for the Miles M52, the supersonic aeroplane. Those were our two big projects which we had in hand, and which were quite advanced by the time the National Gas Turbine Establishment was formed in 1946. That the consequence of the formation of the NGTE was that those advanced projects were cancelled. The Ministry had said in the House of Lords, I believe, that the NGTE would be allowed to design and build engines, but the engine firms rose up in their might, and the Ministry caved in and removed the right to design and build engines from the terms of reference of the NGTE. And that was too much for myself and my leading team members, and most of us resigned.
Can you tell me what the advent of a turbofan, or more properly, what a turbofan was when you first had the idea, and what it would have meant in service, please?
From the earliest days of the turbojet engine, I was bothered by the fact that it has a basically low propulsive efficiency. The thermal efficiency can be quite good at heights, but the overall efficiency is the product of the thermal efficiency and the propulsive efficiency. And this kind of propulsive efficiency you could get was about 50% as compared with, say, a propeller at moderate speeds of 80%. So I wanted to better that. Well, the reason for the low efficiency is because the jet speed is so high in relation to the forward speed. There's a tremendous waste of energy. And so the answer to me was that we must gear down the jet in some way. And that led to the concept of the turbofan, for which I took out a patent in 1936. Now, the turbofan is basically similar to a jet, except that what would be the jet engine as used as a core engine to provide some jet thrust, but also to drive a fan, hot jet that is, but also to drive a fan which provides a large mass, comparatively slow speed jet, as well as in addition to the hot jet from the core engine.
And that increases propulsive efficiency, does it?
That reduces the average jet speed in proportion to forward speed, which has a big effect on propulsive efficiency. With a turbofan, you can expect propulsive efficiencies of 75% or even better if you have a very large bypass ratio. But a characteristic of the turbofan is that it gives a very large thrust for takeoff, static thrust, and then that falls off towards what you would get with the turbojet at very high speeds. At speeds of Mach 2, there would be no advantage in using a turbofan.
So its ideal use would have been commercial?
The turbofan would show good promise for dominating the civil air transport field.
In other words, in 1944-45, you were looking toward the jet engine as a means of commercial aircraft propulsion.
In 1945, we were thinking in terms of, both the long-range bomber and long-range civil transport. That was what the LR-1 was intended for. And as a transatlantic plane, doing then, our target was 450 miles an hour across the Atlantic. And believe it or not, the minister said that people wouldn't want to fly at speeds more than about 250 miles an hour.
In 1945, you had your plans for the turbofan, which would have been a bomber and a civil aircraft engine. What was the official attitude towards that?
The turbofan was a very promising scheme, but unfortunately, for those days, with the pressure of wartime with us, it was rather too complicated, as we thought, for anything to be done about it during the war. But as the war progressed, in 1943, for example, I came to the conclusion that it could be the answer to a long-range bomber for the Pacific War. And so we went ahead with the design of the engine we call the LR-1, which meant long-range LR stood for long range, and we also visualised it as an engine for a transatlantic aeroplane, civil aeroplane.
And in fact, at that time, the supersonic engine was cancelled as well. Presumably that was because the whole supersonic project was cancelled.
The engine for the supersonic plane, the M52, was an aft fan with afterburning, all tacked onto the back end of the W2700 jet engine, and that should have been given sufficient power for the Miles M52 to do 1,000 miles an hour. I think it would have done it, but the whole project was cancelled.
But up to that moment, we were presumably still ahead of the American industry.
The position between 1945 and 1950 was that Britain was really ahead of the world in all forms of gas turbine development, but stupidly we allowed the lead to slip away.
And this is where I think, as you also write in your book, that the one consequence was that those who had founded an industry were deprived of the right to design and make even experimental engines.
When the National Gas Turbine Establishment was formed, at first it seemed as though we were going to continue with our projects, the LR1 and the power plant for the M52, but the opposition of the aero engine firms was so great, and the weakness of the ministry in the face of that opposition was such that it was ruled that the National Gas Turbine Establishment should not design and build engines. So we, the people who had pioneered the whole thing, were deprived of the right to design and build engines. Sorry.
Would it have been possible for you to go into the industry via the aero engine manufacturers? Were you asked by the manufacturers to join them?
When I resigned, I was invited to join Rolls-Royce, but I was still in the service and I didn't want to leave the service. So I became technical advisor to the Ministry of Supply, as it had become then, on gas turbine design. In reality, what I was mainly doing was lecture tours in America, Belgium and Holland and so forth.
Do you not feel, I certainly feel, that to deprive the inventor, the innovator, or put it this way, to deprive the country of the inventor and the innovator was a pretty silly thing to do?
Well, it's my opinion, of course, that when Powerjets was deprived of the right to design and build its engines, that is when I and my team, the people who had pioneered the thing, were not allowed to go on to build engines. It was a shocking waste of what we'd built up.
You still had a great deal of music in you. You could have done a lot more work.
The Powerjets team was still pretty strong and still the best in the country, in my opinion.
And when they dispersed, in fact, they too did not, like you, they did not go into the aero engine industry.
When the team broke up, it's a sad fact that very few of them indeed went into the aero engine business. A few stayed with the National Gas Turbine Establishment, but the leading people went to industry in various forms. Well, they've done good things there. For instance, Bob Fielden built up the Ruston Gas Turbine Division.
You are now, and we are coming to an end, we might have to go on to the next role, but I'll do my best. You are now in your 80th year. You have changed the face of flight. On reflection, has it been a fairly sublime incident, the invention of the engine, or something that sometimes, at any rate, you might be prepared to forget?
I'm often asked how I feel about it, and it's a question I find very difficult to answer. But as things are now, of course, I can't say that I regret anything, really. Things could have been a lot better. We could have had a much bigger influence in the war than happened. But when I see what's happened in the way of civil aviation and military aviation too, but particularly civil aviation, the result, I can only say it's extremely satisfying, especially when you see something like the Concorde. And one of the things, you see, I never foresaw when I was working on this thing, is that I would be a passenger crossing the Atlantic in 3.5 hours, as I have been on a number of occasions. And incidentally, another thing I didn't foresee is that I would have a son who would be flying 747s as a captain in Cathay Pacific.
In 1945, these were beyond even dreams.
In 1945, I could not have imagined these things. So in many ways, things have developed beyond my expectations, even though I was considered to be a crazy optimist.
But you did, in fact, undergo quite considerable suffering, mental suffering, illness. Is that, do you think, the common lot of inventors, or was it something that you personally suffered?
In many ways, I paid quite heavily for the work I did. There was the awful race against time. That dominated life. On top of all the technical difficulties, there were the financial difficulties, there was the skullduggery of people who were messing things up, and it was frustration after frustration, and it took its toll. I began to have a series of nervous breakdowns, and for years, it was years before I really recovered my health.
You would dearly have loved to manufacture, would you? That suggests to me that you were not so much a researcher as a doer. You didn't have the research temperament so much as the production temperament.
I wanted power jets to get into the production field, and I was indeed very interested in production problems. In fact, I think I can claim, or we at Power Jets could claim, that we solved a number of production problems, like the fir tree blade fixing for the turbines and certain things in the manufacture of the compressor. We did solve quite a few production problems, but on balance, I would have been happy to deal with the inventive side of production, because there is quite a bit of invention involved in production, not so much the routine of production itself.
In your case, you had the remarkable experience when you were in your very early 20s, at any rate, of ideas suddenly coming to you. Have you any idea how those ideas form, why it is that one person is gifted with them and another isn't?
I'm often asked how these ideas come, and it's not an easy question to answer. Sometimes they come out of the blue. Sometimes they're a result of seeking an answer, as in the case of the jet engine. Well, I think there's a lot of truth in the saying that necessity is the mother of invention.
The invention of the jet, would you regard that as a bolt from the blue, or a rather carefully thought out step-by-step process?
The invention of the jet was a very slow process, really, because I started looking for something as a result of an essay I wrote at Cranwell, in which I had worked out an equation which I later found out was the well-known Breguet equation. Well, that equation said to me that if you wanted to go both fast and far, you'd need to go very high. So I calculated rockets and decided they weren't much good. Gas turbines driving propellers, and they didn't look very promising because of the difficulty with a propeller at high speeds. And then I went on. I still kept looking for a power plant which would work at high speed, at great height, and thought of the scheme, a piston engine driving a fan inside a hollow fuselage, which Caproni Campini later tried out and found, as I found on paper, that it wasn't very promising. And then one day I thought, thinking about that scheme, I thought, well, why not throw away that piston engine and substitute a turbine? And that was the turbojet. And that was the end of 1939 by the time that particular penny dropped. But it meant it was really the end of an 18-month search.
But it was empiricism. It wasn't just a straight inspiration out of the blue.
It didn't come to me in a flash at all. It was at the last bit saying, why don't I get rid of the piston engine? And,
Fine. Just one question then about combustion, which I've forgotten to cover with you. Can you tell me what the real problems with combustion were and how they were solved? I think it was a man named Lubbock from Shell, wasn't it?
Yes. The combustion problem was by far the worst one we had to tackle. It took us about 3 years really to get the answer. I think we missed it by very narrow margin early on in our combustion test, but we did miss it, and the result was that we struggled and struggled. See, everything else, I was confident about the compressor, and I was confident about the turbine, perhaps too confident, but combustion, you see, we were asking for 24 times the best intensity of combustion in commercial work, and so it was quite a major problem. And though we did many combustion tests, and though we seemed to get the answer in the combustion test, it didn't work in the engine. But fortunately, a shell engineer named Isaac Lubbock, who was head of their Fulham laboratory, was helping us with our fuel problems. And when he saw what we were trying to do, he went away quietly and did some work in his Fulham laboratory and came up with the answer of a burner which injected a fine spray in a swirling stream of air, and that was basically the answer to the problem.
What was it? The diffusion of the fuel successfully in the air, the right mixture?
Combustion is a very difficult thing, and I wouldn't attempt to describe what it is. But you see, you have to get these fine droplets. The finer the droplets, the quicker they'll burn. But the finer the droplet, the more reluctant it is to penetrate the air and get the oxygen it needs. So it's a difficult thing to balance the two requirements.
Fascinating, actually. I didn't realise it was that critical. And, oh yes, just one or two other things what I remember. I think now it might be an idea to say, OK, you had your frustrations, but that certain people, Tizard, Tedder, Roxby Cox, were persons of foresight who did help materially. Would it be appropriate to pay that tribute to them?
Yes, I think so. Well, you know, it was this way. Roxby Cox didn't realise what scoundrels the Rover people were. You know, he still doesn't. I spent last weekend with him. He still thinks Maurice Wilkes was a nice chap. No, I think you'd best leave that.
OK, so shall we say then that in your time you were certainly helped by men of vision such as Tizard and Tedder?
Yes, well, and Tedder, yes. But then, you see, Tizard was too helpful in that he wanted all these other people to get work on it, to have land and so that we had to compete with them for our materials. So we couldn't get... So
perhaps it's inappropriate. OK, as you say, fine. Yeah. I know that you see Concorde as the pinnacle of achievement. What do you see beyond Concorde?
Concorde is a marvellous aeroplane, and I've flown it many times, but I'm looking forward to the next generation of supersonic transports, which I think should be capable of carrying 300 passengers for distances of the order of 4,500 miles, like San Francisco, Tokyo, at speeds of about a Mach number of about 2.3. We're getting up to 2,000 miles an hour, as compared with the Concorde's 1350. But beyond that, I think we're going to see even much higher speeds than that in due course. Unfortunately, they're going to be very expensive propositions.
Do you see that the next generation supersonic being a joint venture with the Americans, or do you think they'll try and do it on their own?
The next generation SST, I think, is going to have to be an international job. I foresee an international company, rather like exists now for the Airbus and things like that, financed by the governments of, say, America, Britain, France, Italy, Germany, and based on some central point, that company to take care of the design and assembly, if you like, while the Rolls-Royce, Pratt & Whitney, Snecma, etc., are subcontractors on engine parts, and British Aerospace, Aerospatiale, Boeing, McDonnell Douglas, Lockheed, etc., are subcontractors on the airframe parts. And they also, I think, would probably be shareholders in the company too.
Do you see a role for hypersonics in the civil field, say from Mach 3-4 upwards?
In theory, it's possible, as has been proved by suborbital flights, to fly from any point in the world to any other point in about 40 minutes. In between doing that and the second generation SST that we've been talking about, there is the hypersonic plane, which I think is quite possible, and I foresee a combination of a turbojet to get it up to the speed of 3,000 miles an hour, a ramjet to get it up to speeds of, say, 6,000 miles an hour, which is ample for hypersonic flight. And then, if you want to get it to orbit from that, you need a rocket for the final stage.
What are we going to talk about this time?
Well, actually, I'm exhausted by it, thank you.
And we're all might do already discussed that.
Whereas we can't exploit the all-night anymore.
Nothing
We have
else.
that already.
I think everyone will be wondering who Doris is.
That's it.
Aviation, the art of aeronautics, began with the dreamers, inventors and daredevils who dared to defy gravity. The journey of aviation was nurtured by pioneers like the Wright brothers, whose first flight marked a historic milestone. The role of aircrafts in world wars was groundbreaking, dramatically changing warfare strategies. This initiated a technological evolution in aviation, transforming the simplistic wings of a biplane into the thunderous roar of jet engines. Let's journey through the ages of aviation. Behind every great aircraft, there were great minds. These visionaries, like Sir Frank Whittle, the innovator of the turbojet engine, redefined air travel. Then there's Skunkworks' Kelly Johnson, the genius behind the SR-71 Blackbird. His designs combined speed, stealth and power, crafting machines that dominated the heavens. The contributions of these pioneers have left an indelible mark on the canvas of aviation, shaping the course of history and inspiring generations of engineers and aviators. Each epoch in aviation history gave birth to extraordinary aircrafts, each with their own unique features and roles. The Lockheed SR-71 Blackbird was a marvel of speed and stealth. The F-105 Thunderchief, a supersonic fighter bomber, was vital in the Vietnam War. The P-51 Mustang, a long-range fighter, was critical in World War II. The P-47 Thunderbolt, a heavyweight fighter, was used extensively in the same war. The A-10 Thunderbolt II, the Warthog, is a close air support icon. The Messerschmitt Me-262 marked a leap forward in aviation technology. Each of these game changers were instrumental in their eras, and their legacies still resonate today. Beyond the game changers, there are those that have transcended their practical roles to become icons. The Concorde was not just an aircraft, it was a supersonic symbol of luxury and speed. The B-52 Stratofortress, a strategic bomber, is an icon of power and resilience. These magnificent machines and others like them have become much more than just aircrafts. They are enduring icons that encapsulate the audacious spirit, the relentless innovation, and the boundless ambition that define the world of aviation. For more amazing aerial footage, and to join us in this incredible journey, check out the Dronescapes YouTube channel.
If you enjoyed this video, please remember to like and subscribe. And as always, thank you for watching.